Welcome to ACE Engineering Academy online platform, ACE Online, where today we are having ACE Preparation League Season 2, and in that we are discussing the preparation strategy for the new subject here, and that is your algorithm. Okay. My name is Abhishek Sharma and I am going to take you through this session. So now algorithm is one of the important subject topic for every computer science graduate, whether he is in academics or he is working in a service based company or a product based company. This is one of the most challenging subject that you are having in your hand, and that is algorithms. Nowadays, if you talk about the product based company, then they are testing the student based on their capability of designing algorithm for a problem in front of them. So they see that how they can apply the concepts of the algorithm and solve the particular problem. So in this session, we are going to talk about this algorithm and how to prepare algorithm for GATE 2023 or 2024. Now here the scope and the agenda for today here in this case for algorithm is very simple, that I will take you through the here in this case is first we will talk about the syllabus, then I'll take you through this some analysis I will present, analysis of GATE 2020, 2021 and 2022. Okay, so there's 4 paper because in GATE 2021 we have set 1 and set 2. So I present you that analysis, and the purpose I might have presented the analysis in the previous session as well, I agree with you, but here the only weight, the focus will be this time on the weightage of algorithm. So we will see the analysis of GATE 2020 to 2022, each and every paper, 4 papers are there, and we will say that how many marks or how many questions asked from that particular topic, which is in this case is algorithm. So we will say this. Then we will see that the distribution of the question, another analysis I am going to present here in this case is that analysis of questions, analysis of algorithm, the subject analysis, analysis of algorithm from questions point of view, question per topic point of view, questions per topic point of view. Now why it is important? Now whenever whenever we are preparing for the competitive examination, we must know the scope of that particular subject, that overall in that preparation, overall in that syllabus where algorithm fits. Okay, first that is the most important point, that I must know first hand that if I am preparing for the aptitude is going to be 15 marks. Okay, this I know before I start preparation, and 15% of the weightage is a huge weightage, and I should focus on this aptitude part more before any other subject, because none of the single subject is having weightage of 15%. So similarly that sort of idea, because other subjects like aptitude and one another, that is your mathematics, is a fixed thing. Okay, fixed means the weightage is fixed, but their weightage is not fixed. Algorithm, they don't mention it. Okay, in brochure they have already mentioned regarding this aptitude part that there will be 15 mark question from the aptitude, and for mathematics they say that 13 to 15 marks. This is mentioned in the brochure of this GATE 2022, that there will be 13 to 15 mark question that will be from the mathematics, and aptitude is 15. But other weightage we don't know. We don't know as a computer science that I love digital logic and design. Suppose I love this, I am very fluent with my concept in digital logic and design, and I love solving the question from digital logic and design. But What is the scope of that particular subject? Okay, I love DBMS, database management system. It's my favorite subject, and I learned every topic, and I master every topic. But where this in overall preparation, with only the preparation of this database management system, how many marks question asked, and how many questions and marks, means what is the weightage in the overall GATE syllabus? That is the important question, and we must see that for each subject where it is fit, that particular syllabus weightage wise. So that analysis will do. So the first part of the analysis will say this thing, that what weightage this algorithm carries, and where it will fit in this entire syllabus of this 100%, where the entire weightage, what will be the weightage of that algorithm. Then we will dig into the another part here, that if we are having the subject algorithm, and if I divide into a different parts syllabus, then each topic is having what weightage. This is the first thing you must do in this case, that whenever you start preparation for a particular subject. Second and most important thing here in this case is order. That means can I start my subject, can I start reading from algorithms? Now here we need some basic backgrounds, not in detail, but we need some basic background for this algorithms. Like what? A bit of summation is required. Then you will say that why summation and what is summation. So here we don't have explicit mention of this syllabus of algorithm, but when you solve question related with the complexity, summation arises. So some form of logarithm arises. Okay, so this is a different kind of type of background required for this analysis of this algorithm, and that is something prerequisite that we have, must be fundamental idea must be clear with that, and that we called it as mathematical background for this algorithm. So that some prerequisite we see, that is one of the part is basic fundamental logarithm concept, the summation concept that we required over here in this cases. Some concept related with functions also required. Okay, function, mathematical functions, that concept is also required for this algorithm. So there are few prerequisite also for the the entire preparation of this algorithm. So mainly I have only 3 topics to discuss. Then I will say that individual subject. We'll get an overview with this weightage and all in the third part, that each topic is having what weightage, and with that we will devise our preparation strategy, and with that also we will devise that what a time we need to devote on a particular topic, and what should be the flow in which we must complete the syllabus, because most of the time we generally go like sequential manner, and sometime what happens in sequential manner is that we focus on the topic, but that particular topic is not having great weightage. That may happen. So that also I'll try to give you insight about that, how the preparation should be for this algorithm, so that at the end of the examination or in the examination you can perform better. So that is something about this agenda here in this cases. Here scope of this subject, one more topic that I have mentioned here in this cases, the scope. This is the most you will find that the scope of algorithm is very vast for a computer science. Okay, now here every big companies, if you're going, I'll pray that you go for you join the big company. So all the big companies, not only from the GATE preparation perspective, but from the placement perspective also, they are focusing on these algorithms, and not only learning the methods, learning the design technique, but also we should be focusing on how we can apply this thing. Okay, how we can apply the divide and conquer to solve the problem, how can we apply greedy method to solve the problem, what are the basic characteristic that must be satisfied so that I can apply the greedy method. That sort of understanding required. That means that we need to go deep into this particular subject, design point of view. Okay, but we'll answer this question: is design is that much important for the GATE examination? Let's see. So now the syllabus here is here in this case is algorithm is the mention in the syllabus, but we have two part of this syllabus. That one is the design part and another is analysis of algorithm. So basically they prefer, we prefer actually to call it as DAA. The short term is DAA, and the design and analysis part. So there is a two aspect of this algorithm, that there is a design aspect where we talk about designing of algorithm as a divide and conquer. Greedy method, and the third is your dynamic programming. So that is the design aspect, dynamic programming. So that is the design aspect. Analysis aspect is all about your asymptotic notation. Okay, so asymptotic notations. Okay, asymptotic notation, and that's why though the name is algorithm, but we call it as design and analysis of algorithm. Look at the syllabus here, section 5 in this GATE brochure, and in this case start with searching, sorting and hashing. That is the first part. Searching and sorting is a linear search, binary search. Sorting is a bit of, it's a open, like say in this case you cannot bound this particular topic. So generally we talk about the basic sorting algorithms, insertion, selection and the bubble sort. And after that there is a counting sort, there is a shell sort, so limitless, radix sort is there. So that is sorting, that is the one first part that start the syllabus with. Then it says that asymptotic worst case time and space complexity. That aspect is basically the analysis part. So this is what I was talking about, the analysis, and the first thing that we must be able to analyze the algorithm by using asymptotic notations. So analysis is for the asymptotic notation. So that is first thing, asymptotic notation. What is next here in this case is the design part, algorithm design technique and greedy, dynamic and divide and conquer. What it does not mention is that what algorithms we have to learn to for this design technique. It doesn't mention here in this cases, and that is not only for the CS or the only for algorithms. Syllabus are not something that is very clearly stated in the brochure. They never say it, they say the terms. So now here greedy, dynamic and divide and conquer. Then it mentioned here graph traversal, okay, and again in this case is a pretty a small thing said about the graph traversal, because graph traversal is only BFS and DFS. No, that is not enough. We have to go deep into this. We have to learn many applications that is related with BFS. I will talk about this in the next section. Then you will find very interesting in this case is that a minimum spanning tree has a mention separate than this greedy. So greedy is not mentioned, greedy is mentioned separately and spanning tree is mentioned separately, and finally the shortest path is been mentioned in this case. So here here I will not included the analysis of hashing in this cases, but rest of the topics are included in this case. Hashing is not included because here we consider this more as a data structure rather than an algorithm part in this case. That is your syllabus. So solid understanding of syllabus is required. Is it a clearly stated syllabus? So answer is no, it is not. Everything is not mentioned here in this cases. Like what algorithm we need to do, how deep we need to go to the graph traversal, minimum spanning tree, algorithm, not algorithm, strategies, shortest path, nothing mentioned. So many things is not mentioned here in these cases, but that is our syllabus. Now we'll come to the analysis and we'll see that how the paper was divided in 2022, and I present you this the analysis. Every subject is here in these cases, but we are focusing on this algorithm part. So in 2022, okay, in 2022, the topic which was in case of this analysis was algorithm was 8%. 8% means in this case I will say 8 marks question asked from this particular topic. 8 marks question. So 8 marks question asked from this particular topic, and among this 8 marks, 3 questions were 2 mark. 3 questions that was asked is of 2 marks, that make it 6, and 2 questions, okay, 2 questions asked here in this case is 1 marks, and that makes 3 into 2 6, 6 plus 2 in this case is 8. So 8 marks question was asked from this particular topic. But I will say that this year the algorithm question and the data structure questions were not that easy compared to previous year. Both were equally challenging, okay, both were equally challenging in these cases, and it was, it's not very straightforward journal question from this algorithm we get. They have gone deep into this spanning tree. This year they have asked very difficult question from the particular topic graph, from discrete mathematics perspective, and from this perspective which is your spanning tree, or that is algorithmic perspective. So very difficult question was asked this year, but that does not decide your preparation strategy. That is one thing that always keep in mind, that this year question will reflect next year, no. This kind of question will again come, may or may not. Will every question of this category? No. So one of the things that you have to keep in mind while making or doing the preparation is that we always judge the entire paper based on a few difficult questions. So we judge the paper, don't judge the paper. This is the first thing, that don't judge the paper based on difficult question. Based on difficult question. So will it be there, like, is it a true statement that next year also there will be 4 or 5 difficult questions? Yes, it will be there. It is guaranteed that in the next year also you will get 4 to 5 questions, which is, believe me, it will be difficult to solve in the examination. This will happen, but that does not decide the entire paper. What I will say, you are only looking the difficult part. I will say that there are questions which are also solvable. So the overall, that you should not judge the paper based on this. Yes, there, and accept this, that in the GATE examination some question you will encounter that is difficult, but cleverly what you need to say, what you need to do in this case is, you have to decide whether I should go and attempt it or I should skip it. Should I waste my time on solving that particular question, or I should solve maximum number of questions. So one of the preparation strategy that you have to adopt is that you have to practice skipping the question. Attempting the question is important. Yes, that will give you the marks. But I believe that the student who are the best, who can best judge the particular question, whether we have to attempt or skip, whether attempting this one will take this much time, and in this particular time duration I can solve, let's say, 3 more easy question or 3 more moderate question. It's a lengthy calculation. So that judgment, the student that can judge this thing is definitely going to optimize this. Then who can judge this particular question, that this is that question is difficult and that much time it is going to take? The student who is having thorough understanding of entire topics for that particular subject. He has solved the question from the spanning tree. And he has seen all the previous year question from the spanning tree. He knows the standard of the spanning tree, how easy a question can be, how difficult a question can be from the spanning tree. Now ask yourself that did you complete that particular spanning tree part? Did you complete all the PYQs from the spanning tree? Then only you can decide whether the next question that will come in the examination from the spanning tree, is it an easy question or difficult question? Can I go ahead with this particular question? Or should I skip this question and solve another question which may be moderate or easy? So the judge, you don't need to judge it, and only thing that is the basic idea of greedy method and dynamic programming, optimization. Okay, you don't need to solve every question. Even toppers never get 100 by 100. Maybe he has not solved that a difficult question. Maybe 81 marks, so where the 19 marks gone? He didn't find some questions, the topper I am saying. He didn't find that this question should be attempted in the examination. Simply. So the best idea, he is judging the question based on their merit. And you should also do this thing. You have to do the optimization, that you need to solve maximum number of questions. Maximum number of questions. And not every question. And not every question. Every question no one solves, even topper doesn't solve that question. So that was one thing. Second important thing regarding this, regarding the preparation strategy, one is the optimization thing. Second is the mistakes that we commit here in this case, that there are two aspects of this competitive examination. And most of the time we focus on, there are two aspects. One aspect is learning the concept part, concept learning. For example, I will say one concept that is equal to, suppose you learn how this Prim's algorithm works. You learned the thing from various sources, concept learning. And what as a faculty we do actually. What as a faculty we do, we teach you the concept. And what we do? We solve, let's say, 4 to 5 questions related on let's say Prim's algorithm. That is, Prim's algorithm is a spanning tree algorithm. So I'll explain you the concept with best of my understanding, and I try to simplify as much as possible for you this particular concept of Prim's algorithm, and I will solve some question so that I can also say this thing, that how this concept can be applied on a various different set of problems. That means I'll give you a graph and various different instances, and I'll calculate some spanning tree for this. So I have solved 3 to 4 questions. Now, the thing is that what a student is, it will learn and it will solve the question. He or she will make the mistake, I will rectify. Now you tell me that after learning the concept and plus here in this case and solving, let's say 3 to 4 questions. Solving, let's say 3 to 4, because in the class we cannot go on solving question, 3 to 4 questions. Can you, as a student, you can claim, can a student claim that he has mastered the concept of the Prim's algorithm? Can you say this thing, that yes, now I learned everything about Prim's algorithm? Okay. So answer is still no, okay, still no. You have to go into the field in a sense, you have to go into the battle in the real examination and test yourself whether can you apply this concept not only in the classroom but in the examination. When the pressure is there, when the timeline is there, in that pressure situation, when you are feeling nervous, can you recall the concept of Prim's algorithm and you can solve a question from the examination which is one of the difficult, we don't say most difficult, but one of the difficult examination for the computer science, the GATE examination. Can you do this thing with only doing this bit, understanding the concept and solving 3 or 4 questions? Answer is depends. Depends upon your understanding, depends upon how much skilled you have gained because of this small practice. So that differ from student to student actually. Some students are very sharp and they are so much skillful that they will learn this concept within minutes. Other may have some problem in learning the concept, understanding it entirely, and then the next thing is become the application, that applying it. If you are facing difficulty in learning the concept and then applying it, that means you required more and more practice. Practice is the key. Now in the examination, applying the concept and getting the correct answer. Applying concept and getting correct answer. Different from learning. You know Dijkstra method, you know Prim's method, but when you have applied in the examination, applying the concept and getting the correct answer, this is equally important part, getting the correct answer, your end result must be correct. So there are many barriers are there. You look at the barriers that for each concept the barrier has to be crossed. First start with learning. Second, this is the teacher's part, that it is solving 3 to 4 questions. Practice, you lack it. Student lack practice. You have not solved sufficient question, and if you believe that solving 3 or 4 question, it give you a sense, okay, when you are in class it will give you the sense that you completely understand this concept, this feeling will come. But did you test yourself on this? Did you try any new question and try to apply that one? Because in the class, the faculty, the teacher is with you. He is guiding you. And where you are making mistakes, he is just correcting it. So you are solving that question with help of a faculty or a teacher. But did you explore that question, more question, where no one is there, and are you able to solve that question and get the answer? So both things I consider different. Knowing the concept is a different thing and getting the correct answer is also a different thing. In this getting the correct answer process, there is one more possibility that you may get confused or you may get different answer, and you might end up with making some silly mistakes. Calculations are there, and you have done everything correctly, you know the concept, but now somehow you are not reaching into the answer. So now there are many stages are there that you have to cross for single concept. Learning the concept, practicing few problem in class, solving few problem in class, then go through the practice session, rectify your mistakes, then finally if you are in the examination, you can apply the concept and get the correct answer, avoiding all the silly mistake, then only you are going to earn that 2 marks. All the hurdles you need to cross. And that is why I personally feel that as a faculty, my contribution in your preparation becomes very minimal. Later, where I am present here, I am present only in this phase. Here I may or may not be present. Practice, you are doing cutting confusion. Okay, fine. I am there for you. I rectify that one. But here, most of the practice you have to do. Finally, apply the concept. Getting the correct answer is up to you. So, teacher's role is very minimal. You understand this. In your preparation, you do remember that a teacher is playing very little role. It is up to you. You have to practice and practice avoiding the silly mistakes and finally getting the answer. So our preparation strategies, you have to know, first thing is your confidence must not be shake if you are looking or if you are seeing the difficult question. Skip it. I'll solve next one. Optimization. It is not about solving every question. No one can solve. In the history, no one got 100 out of 100. Some questions are there to waste your time. That you have to remember. Some questions are deliberately created or put into this paper so that some of the students waste their time. That identification is very important. Optimization, solving maximum number of concepts and getting the correct answer. This whole thing that I am writing is about getting the correct answer. That is also important, as important as getting the concept correct. You know the concept, but you are not getting the correct answer. What is the use of it? Nothing. Moving forward here in this cases, this is the next. I present you the analysis of 2021. We had two papers in this, the set 1 and set 2. So in set 1, okay, in set 1 we have this algorithm ask 11 marks of this question. This is marks, percent is there out of 100. So there are 11 marks of the question asked from this particular. So high weightage, yes. Who is in the double digit? Aptitude. Operating system is in the double digit. Some are not visible in this case, but that is 11% is very high. So previous to this it was 8%, now here in this case is 11%. The next is from the set 2, and again you can see that 10% of the question, 10% or 10 marks of the question asked from the algorithm, and that clearly suggests past 3 paper, okay, that the percentage of the weightage for the last 3-4 papers, because in 2021 we had 2 papers, set 1 and set 2. 22 we had only single paper, and 20 also we had the single paper, where again in this case the here the weightage is the 7% of the weightage here in this case. So slightly dropped. So let's look at here in this cases all the weightage one more time, so that 8%, 7, 8%, here in this case is 11%, and the next weightage here in this case is 10%, and here in this case is 7% of the weightage. Okay. Now I have presented you the analysis so that other subject also you can focus on, and you can see that what are the different topic is having what different weightage. Then I summarizes the everything within this table, and I have analyzed the paper from the 14 onwards. Like in 14 we have 3 paper, 15 we had 3 paper, 16 2, 17 2, 18 and 90, back to 1, 21, 21 and 20, 1 set 1 and set 2. So that is the analysis that we have done. If you look at the marks part, then you will find that varying 12, 7 and 7 in 14, then 10, 7 and 10 in 15, 3 different paper but varying the marks, and here 16, 9 and 11, for 17, 6 and 10, For 18, 8 and 8 and 19 was the lowest, that is 6. 8, 11 and 10 for 20, and for 2022, the marks was asked in this year was 8. Okay, the 3 2 mark and 2 1 mark question. So if I just summarize that, the lowest marks, lowest marks was 6, 2018. Okay, lowest was 6, and let me see highest, 11 I guess. Okay, 12. So 12 is the highest marks that was asked in this particular topic. So here the lowest is 6, lowest marks. Was 6, and the highest marks was 12. Okay. Based on this, can we say no? We generally take the average of it. We'll take the average of this value, average of the number of question asked here in this cases, and we find that you can expect on an average 5 to 6 question average value, and you can expect the marks as 8 to 9 marks. So around 10% or around that. 7 is also possible. So in this case 8 to 9 marks or 8 to 9% of the marks will be asked from this algorithm. That is the prediction, and that is the average value, the number of marks that has been asked. So what marks, how much marks we are fighting for in this case is 9 to 10%, you can say 8 to 10% also you can say. That is the weightage of this subject for this algorithm. And this is something important because we must know beforehand that this subject is having what weightage. Right? Now, here I will also give you one more like a clue here in this case is that what are the important topic and what are the important subject that we have in our hand. This is a, let's say I talk about, okay, let's talk about this year only, 2022 let's talk about. So in 2022, if I talk about that, what are, how to prepare here in this case is how to approach. So everything is fine, but I believe in rule of 50%, and you will find that certain subject which is in combination, like here engineering mathematics, okay, engineering mathematics, maths, and discrete mathematics, discrete maths. I believe that every weightage is available, sometime it is not available. So you look at here 11 and 6, together discrete mathematics is 11%, which is usual, higher than the usual, and it is 6%, so 17% question over here. Then comes your aptitude. Okay, aptitude, that is straight away 15. Then comes your, in this case is programming language and the data structure, which is 9. So DS, PL and DS, data structure and programming, which is single subject actually, which is equal to your 9%. 5 for the programming and 4 for the data structure, 9%. And then you come to this finally algorithms. And that is in this case here is only 8% of the question. Now here if I just sum it up, 11 plus 9, 20, 35, 41 and 8, 49%. This is a paper where you can say that your half of the syllabus, then you can say the rest of, but how many subject? 5 subject. So now you can say that here half of the syllabus is covered by mathematics, aptitude is mathematics, and logic, which is algorithm, programming and data structure. So mathematics plus logic is 50%. Logic means logical, because this subject data structure and programming is basically required logical reasoning, right? Logical reasoning. Here also in analysis also a lot of logical reasoning is required. So good with logical reasoning, good with mathematics, good with aptitude, 50% part you will cover. And guys, understand that in 25 marks you qualify it. So qualifying is pretty easy in the GATE examination, but that should not be your target. I am not saying qualify the examination. No. What you will do with a scorecard? It will just a statement or sentence in the resume. Is it of no use? Until and unless you are getting the good rank. The second thing students are most confused with is what is the sufficient marks and ranks. But that I have discussed in my last preparation strategy, that how much marks you required and how much marks will take you which rank. An IIT, what rank is required, for NIT what rank is required. That I have done in the last video for DSA preparation strategy. I will not show you again this. But that is 49. Then you may said, okay, this is a like random, you have picked this only one paper, you cannot comment here in this case. Okay, fine. I'll show you one more time. If I have a few availability of in terms of, okay, I don't have all the data available in this cases, but I can show you that certain things, even right now I need to pause it and I need to again recorrect it. I'll see that if it is present here, yes, here I can show you for set 2. So look at here, discrete mathematics 7%, DM is 7%, engineering mathematics EM is 8%, algorithm is 10%, algorithm is in this case is 10%, already we have 25%. Next is aptitude. 15%. Fix. Next is programming and data structure, and that in this case is 9%. Programming and data structure is 9%. So this programming and PL, programming language, and DS, in this case is 9%. Look at this, the weightage, and tell me 15 plus 10, 25, 40. Again it is coming here surprisingly around 49%. So that is a rule for this preparation for the GATE examination, that the 49% of the time your questions are restricted to 5 subjects. What we need to do? We have to focus on this subject more. That will decide. And rest is definitely you need to cover all the syllabus. So that is my rule for 50%, that the 5 subject covers the 50% of the syllabus, and that is something for you. This is my average value that I am expecting this year, that 5 to 6 questions will come, and that will consist of 8 to 9 marks. Now here this is also a very common question, do we need to get to the book? But understand, this is the Bible, for computer science. Those like here in this, even my brother who is working in this at the company for the electronics VLSI, Mentor Graphics. So he also sometime refer this book. And it has been, he's working there from 2006, so it's been always 12 years of experience, 12 years of experience. Still he refers to that particular book in some cases. So that is the importance of this book. That is your core man. And another book that we are familiar, that as a faculty, as a teacher, we take the content, and our content source of the content is this 2 book only. And you won't believe that from this book, the exercise question from this algorithm, this book, there are questions in the GATE examination which belongs to the exercise of this core man, popularly known as CLRS. Okay, this is popularly known as the CLRS. That is the book you need to refer. Now, The main part, what is the weightage and how this weightage is going to take us forward into this. So I present you the weightage from 1991, okay, 1991. This is not the marks analysis, to 2021, 2021 up to this. These are the weightage of questions from each topic, okay, questions from each topic in syllabus. So the thing that was there in the syllabus, the same thing that I put it over here. Like here, asymptotic, worst, and time space complexity. Look at this, the weightage. 33% of the question belongs to asymptotic analysis part. So as I said that there is a two section, analysis and the design. You can say 33% questions are from this analysis. 1/3 till now, and that makes your analysis as the most important part. Now do not forget what? Do not forget that recurrence relation was not mentioned in the syllabus. Syllabus does not say that read recurrence relation, but we study recurrence relation. Where we study? When we do the analysis, and we study a lot actually, when we do analysis of recursive programs, okay, when we do the analysis of recursive program, in that analysis recurrence relation is generated, recursive program analysis. Then we solve the recurrence relation by substitution, by master method, by recurrence tree method. That is the depth of the analysis in terms of recurrence relation. We need to master three methods in this case, all the three: master method, substitution method, and then recurrence tree method. After that, you will find that in discrete mathematics also we solve the recurrence relation by method of finding the characteristic root. Then the term comes homogeneous and non-homogeneous equations, recurrence relations. So there is a method of finding characteristic root also in recurrence relation, but that don't study in case of algorithm. So now if I just combine this, that how many questions from analysis and everything, it is including every question, that is the analysis is required, not only the notation but the program analysis, the complexity. You find that 38% question is from that topic, which is asymptotic, worst, and time space analysis. That makes it the most important topic. So single-handedly you can see that if you start your preparation, then start the preparation from this asymptotic analysis and recurrence relation, and spend as much as time you can, because this year also there was a question from recurrence relation. 21 I'm not sure actually, I don't remember exactly, but in 2020 there was a question related with the recurrence relation. It is important. Now what can you see the next weightage here in this case is, the next weightage you can see is 17%, which is searching and sorting. Very surprisingly, 17% question from searching and sorting in this cases. Now here the weightage for is increased more because of inclusion. In this case I have included two algorithms, that is quick sort and merge sort, and then the rest of the sorting algorithm, quick sort and merge sort algorithm. So because of this inclusion of quick sort and merge sort, the weightage, the percentage of the weightage for this sorting increases. They belongs to where? They belongs to divide and conquer. So if I consider that my the divide and conquer strategy, the quick shot and merge shot, the total weightage will become 17. That is the second most important topic if I consider the previous trend. That there is a high chance that there will be question from sorting, and specifically in that sorting I can say there is a high chance that there will be question from quick shot and merge shot specifically. So that is important. So now how to approach this? Approach is asymptotic, second is searching and sorting. The third topic that is having more important in this case is spanning tree. Can you believe this? Can you believe that a single topic, okay, a single topic which is comprised of only two concepts, the Prim's concept and the Kruskal concept, because that is how the spanning trees are created by algorithm, following the algorithm. So that is basically where we learn. When as a teacher we teach this thing in greedy method. We teach this thing in greedy method. But you will find that a single topic of huge weightage. This year there were two questions related to the spanning tree, and both are 2 marks. 4 marks question was asked this year 2022, and I guarantee this thing here that, mark my word, that there will be next year also there will be question from spanning tree. That is the importance of a single topic. Even if you look at this searching and sorting, so searching and sorting is not a single topic, comprised of selection, bubble, insertion, quick, merge, heap shot, counting shot, radic shot. So many topics are there, but here there is a single topic, only spanning tree, single topic, largest weightage, 15%, question guaranteed. So next year again there will be questions from the spanning tree. How to prepare this? My single suggestion to you to prepare a spanning tree and solve the question related with spanning tree. Solve every PYQ question. Every PYQ. Plenty of PYQ starting from, let's say, 1991. Go back. Solve the theoretical question as well. That 15%. Then you get a shortest path here in this case is this particular part, shortest path, which is 5%, which is relatively lesser. Yes, I agree with you in this cases. Okay, fine. I forget one. The graph. After that, spanning tree, the graph part. What does the graph part suggest and what is the graph part contain? So now graph, what was mentioned in the syllabus? It was mentioned only graph traversal. Then what? Graph traversal is having only BFS and DFS. Then what? BF and DFS. What we need to do here in this case is that we need to do the DFS for directed graph. And in the DFS for the directed graph, all the question belongs. Traversal is there, I agree with you, traversal questions are there. But nowadays the trend has been, recently, the focus is on application of DFS for the directed graph. Classification of the edges, cross, backward, forward and tree. 4 types of edges. Classification of the edges, application wise of the DFS, topological sorting, strongly connected component, bi-connected component. In 2021 there was a question from the first time, only 2 questions asked from the bi-connected component. One was very, asking the articulation point. But in 2021 there was a question related with bi-connected component. In fact, in 2021 there was a question that is comprised of MSQ and consists of 4 different statements. Strongly connected component, back edge is present or not. Topological sorting, all this were present in a single question, and that is the lengthy MSQ question, and that was nothing but the application of DFS, and that's why the weightage here in this case is higher. Shortest path here in this case is, if you go for the shortest path, don't look at this. Okay, I can have this. Okay, shortest path. So in shortest path you can have the weightage only 5%, and that here in this case is most of the question belongs to your the Dijkstra method. Okay, the Dijkstra method, that belongs to the greedy. Now what is quite interesting in this case is that here it is become 38%, then 38 plus 7, 45, 55, 60, 60 plus here in this case is 11, that is your 71, and here in this, if you just apply the method here, okay, I think I have counted 33 plus this, you will find that 84% of the question, if you sum it up, this 15, 5, 17, again 5, 33, and then you find this 11. So rest of the subject, that is only 14% of the question left for the design part, where please remember that what I am saying is that quick, he is considered here, quick shot, and merge shot is considered here, spanning tree is considered here, and shortest path, the Dijkstra, is considered here. If I consider this topic over here, okay, and then I left the other part, only 14% of the question. That means rest of the algorithm, max min problem from the divide and conquer, then other problem related with this divide and conquer, the longest commons, maximum subarray problem from divide and conquer, dynamic programming, matrix multiplication, LCS problem, longest common subsequence problem, multi-stage graph problem, okay, and the knapsack problem, okay, they all having a least weightage in this case. So this weightage says, but it doesn't mean that I am asking to leave this particular topic. The discussion of this preparation strategy, okay, is to focus more on this part which is I have already shown you. 86%. Preparation strategy means what? How to move forward with this particular subject. That is the preparation strategy. Preparation strategy doesn't mean here in this case is that I need to be selective about my preparation. I am not saying be selective about your preparation. Complete everything. But you also remember that the main part that we need to do, and we guaranteed question. What guarantees the question? Asymptotic analysis guarantee, recurrence relation guarantee, graph guarantees the question, spanning tree guarantees the question, searching and sorting guarantees the question. So if there are 5 to 6 questions are there, then they belongs, definitely there is a high chance that they will belong to this topic rather than the design part that we learn. So many things, Hoffman coding is there, that is also important topic. Apart in this 14%, Hoffman coding is important, and there are many algorithms that we learn. The Bellman-Ford, that is the algorithm for graph. The all pair shortest path we learn for the graph. Two traveling salesperson problem we learn for the graph. That all belong to that in this 14%. So that is the actual weightage that you are having here in this cases. The rest is belong to 14%. So this is the way you should strategize and you should move forward. Okay. So this is that is something from my end for the preparation strategy of the algorithm, guys. Please remember one thing, that applying the concept, learning the concept is only, I believe, that only the part that is 33%. Practice a lot. Okay. Practice a lot, and this subject is one of the subject that will take you forward not only in this competitive examination preparation, but in your career also. It will be very beneficial if you can command on this particular subject. On that note, I wish all of you best of luck and for your preparation, and I'll stop my session over here. Thank you very much for listening to me, and have a very good day ahead. Though it is over, but have a good night. That's all from my end. Thank you very much.